In this video, we are going to go over molar mass and how to convert between mass and moles and mass. So previously, we learned about atomic mass, and we used atomic mass units, AMU. Now, this is also equivalent to a molar mass in units of grams per mole. So 1 AMU, or atomic mass unit, is equal to 1 gram per 1 mole. And we can abbreviate that as 1G for gram over MOL for mole. So as an example, on the periodic table, we can see that carbon has an atomic mass of 12.01 AMU. And this is equivalent to, or equal to, 12.01 grams per mole. So notice this is going to help us convert between grams and moles and vice versa, because we can write this as a conversion factor. So notice that we have grams in the numerator and moles in the denominator. So now that we know that carbon has a molar mass of 12.01 grams for every 1 mole, what does that mean? So if we used a balance to measure exactly 12.01 grams of carbon, we would know that that is equal to 1 mole of carbon. And in the previous video, we saw that 1 mole of something is equal to Avogadro's number of that item. So in this case, if we weigh exactly 12.01 grams of carbon, and you can actually see that in the picture on the left, that is equal to 1 mole of carbon. And 1 mole of carbon is equal to Avogadro's number of carbon atoms. So it's all connected. All right, so let's practice calculating the molar mass of a compound, in this case, sodium chloride. So if you want to pause the video and calculate the molar mass of sodium chloride, feel free. This will be exactly the same as how we calculated the atomic mass. So you'll just find the mass of sodium, the mass of chlorine, and add them together. All right, so if we look up the mass of sodium on the periodic table, its mass is 22.99 AMU, but in this case, we want the molar mass. So instead of using the unit AMU, we'll use grams per mole. And then chlorine's mass is 35.45 grams per mole. So if we add those together, we'll get a total mass for sodium chloride that is 58.44 grams per mole. So what this tells us is that 1 mole of sodium chloride is going to weigh 58.44 grams. And we could go a step further. So we could weigh exactly 58.4 grams of sodium chloride. And since we know that that is equal to 1 mole, we can also say that's equal to Avogadro's number of sodium chloride. Now, for ionic compounds, we tend to describe those as formula units. So instead of saying molecules, we would say formula units. And remember, this has to do with the crystal lattice that forms for ionic compounds. So instead of just one sodium ion and one chloride ion, we actually have alternating ions in a crystal lattice. And the formula, NaCl, is just describing the lowest ratio between the two. So a formula unit in this case would be Na and Cl. All right. So not too bad, right? Calculating the molar mass. So now how do we use that in conversion problems? So if we're using molar mass, we're converting between grams and moles. So for example, let's say we're starting with moles of a substance. So maybe we were told the amount of substance that we had in moles, and we want to convert that into the mass in grams. So what we would do is we would take what we're given, which is moles, and we would use the molar mass as a conversion factor. And since we're trying to solve for grams, we're going to multiply by the molar mass. Oh, my pencil doesn't want to work here. There we go. Now, what if we're going the other way? So maybe we're given the mass of the substance, and we want to convert that into moles. So going the opposite direction, we're actually going to put moles in the numerator, since that's what we're solving for, and we'll divide by the mass in grams. So the other way to say this is that we're going to divide by the molar mass. So we're flipping that conversion factor over. So again, in general, for these types of problems, write the given quantity first, then determine the proper conversion factor. We'll cancel the original units or the given units that we start with, and then we'll multiply and divide the numbers that are left over to get our new quantity with our desired unit. All right, so again, we can use molar mass as a conversion factor. And let's look at the specific example of water, H2O. So the molar mass of water is 18.02 grams per mole. And if you want to verify that, you can always look up the mass of hydrogen and the mass of oxygen and add all of those together. But let's say that we want our final answer to be in grams. So we're solving for the mass. That means we want to put grams in the numerator. So we would write 18.02 grams of water over 1 mole of water. But what if we're trying to solve for moles and we want moles as our final unit? Then we're going to flip that conversion factor so that 1 mole of water is on the top and 18.02 grams of water is in the denominator on the bottom. So let's do some practice problems. Let's say we're trying to figure out what is the mass in grams of 2.3 moles of water. So let's do this first one together. So let's see, we're trying to solve for the mass. And we're given 2.3 moles of water. So remember from our flow chart earlier, we want to start with what we're given. And then we want to use the molar mass to convert to grams. And remember, in our chart, if we're going from moles to mass at the top there, we want to multiply by the molar mass. We also saw that on this slide. If the final answer should be in grams, which in this case that is the case, we put grams in the numerator. So we're going to use this first conversion factor. All right, so again, we want to make sure our units cancel. So moles of H2O will cancel with moles of H2O, which gives us our desired unit in grams. And then if we simplify this, we're really multiplying 2.3 by 18.02. And again, our unit will be in grams. So putting that together, I got a value of 41 grams of H2O. So let's also think about sig figs here, because we haven't talked about that quite yet in our calculations. And it's been a while since we've talked about sig figs. So when we're multiplying and dividing, do we care about the number of sig figs or the number of decimal places? The number of sig figs, right? So how many sig figs do we have in 2.3? 2. And then our molar mass is 18.02. So how many sig figs would that have? 4. And remember, we want to limit our answer to the least amount of sig figs because we can't be more accurate than our least accurate value, for example. So that's why I wrote 2 sig figs in my answer, because I was limiting that answer to 2 sig figs. Let's see, for number 2, how many moles are in 4.2 grams of H2O? Okay, so let's see. Maybe try this one on your own first. So pause the video, see if you can figure it out, and then we'll go over it together. Okay, let's see. What are we solving for and what are we given? So we're solving for moles of H2O. And we're given 4.2 grams of H2O. So again, we're going to start with what we're given, 4.2 grams of H2O. And like we saw earlier, if we're solving for moles, then that means we want to divide by the molar mass. So we're going to flip our conversion factor. So that means we're going to use this conversion factor up above on the right. So 1 mole of H2O will go in the numerator, and 18.02 grams of H2O will go in the denominator. All right, so let's make sure our units cancel. So grams of H2O cancels with grams. So that leaves us with our desired unit of moles. So if we simplify the math here, it looks like we're dividing 4.2 by 18.02. And then we have our unit there. And how many sig figs should we have in our final answer? 2, right? We were given 2 sig figs in the value, 4.2 grams. And we already said that the molar mass had 4 sig figs. So we're going to limit our answer to 2 sig figs. So I got a value of 0.23 moles of H2O. So I have 2 sig figs there because that first 0 is a leading 0, right? So we don't count that as a significant figure. We could have written this in scientific notation to avoid leading zeros. That's also a possibility. All right, so hopefully not too bad so far. Just doing some simple conversions here. Let's do another practice problem. So in this problem, you're asked to calculate the molar mass of magnesium chloride, MgCl2. And then once you have the molar mass, you're asked what is the mass of 0.52 moles of MgCl2. So see if you can do this on your own. Pause the video, and when you're done, unpause and we'll go over it together. All right. So let's start by calculating the molar mass of MgCl2. So the mass of magnesium, according to the periodic table, is 24.31 grams per mole, since we're using molar mass here. And then we have 2 chlorines. So the mass of chlorine is 35.45, but we want to multiply that by 2. Okay. Now, if we add that all up, we should get a total mass of 95.21 grams per mole. Now, if you're plugging this into your calculator, remember to put parentheses around 35.45 times 2. Otherwise, you're going to multiply everything by 2. And we only want to multiply the mass of chlorine by 2, not magnesium. All right, so in the second question, we're asked what is the mass of 0.52 moles of magnesium chloride? So we're given the amount of moles, so that will go first, and we want to figure out the mass. So that's what we're solving for. And remember, we can use the molar mass up above as a conversion factor. So we could write this as 95.21 grams of magnesium chloride over 1 mole. Or we could flip it if we are solving for moles, right? But in this case, we're solving for mass, so we'll leave mass in the numerator. Okay, so let's start with what we're given, 0.52 moles of MgCl2. And then we'll multiply by the molar mass. And again, we always want to make sure our units cancel. So moles of MgCl2 cancels with moles in the denominator of our conversion factor. So simplifying this, we are multiplying 0.52 by 95.21, and our unit is grams. Now, how many sig figs should our final answer have? 2, right? Because there are 2 sig figs in our starting value. There are 4 sig figs in our molar mass, and we want to limit our value to the least amount of sig figs. So, for example, my calculator gave me 49.5 grams of magnesium chloride. But since we have to limit that to 2 sig figs, I'm going to round up to 50. And I'm going to put a decimal after the 0 to indicate that 0 is significant. Now, we could also write this in scientific notation, so I'll show what that looks like too. So we could have written this as 5.0 times 10 to the 1 grams. So either way is fine, but I just wanted to show you that there are options if you're not sure how to express your value with the right number of significant figures. All right, so either way, we have 2 sig figs if we write it as 50 with a decimal, and then we have 2 sig figs if we write it in scientific notation. Okay, so I think we'll stop there for this video. Let that kind of absorb into your head, into your brain. In the next video, we're going to see how to convert between moles of one substance and moles of another substance. So I will see you then.